The next method that I'd like to look at for solving quadratic equations is called completing the square. This method builds on the idea of taking a square root to solve a quadratic equation, and this also works best when the coefficient on x squared is equal to 1. If you start out with some other coefficient like 2x squared or 3x squared, the very first thing that you'll have to do is divide all of the terms by that leading coefficient so that the leading coefficient equals 1. After that, here's the steps for completing the square. We rearrange the equation so that it looks something like this: x squared plus bx equals c. So the x terms are on the left side, the constant term is on the right side. Then we add a very specific amount to both sides. We add b over 2 squared. Whatever this value is, it's a numerical value. We take that and add it to both sides. I can do that because I'm just keeping the equation balanced by performing the same operation on both sides. And that number is very carefully chosen so that the left side of the equation can be rewritten as a perfect square. We'll see that in the examples here. Finally, if you have a perfect square, you can simply take a square root to solve your equation. So let's look at this one: x squared plus 6x equals 1. It's already in this form with the x terms on the left and the constant term on the right. So I'm going to imagine adding something to both sides of this equation in order to create a perfect square on the left. So my rule here said take that value b, divide it by 2, and square it. So here's the value b. 6 divided by 2 is 3. 3 squared is 9. So this is the amount I want to add to both sides of our equation. Let's add 9 here and add 9 here. We're keeping this equation balanced. What's the point of adding that amount to both sides? Well, I'm claiming that now the left side of this equation can be factored and written as a perfect square. X squared plus 6x plus 9 is the same as x plus 3 times x plus 3. But this can be rewritten. X plus 3 times x plus 3 is the same as x plus 3 squared, and that's equal to 10 on the right side. So I just rewrote this equation, and I formed a perfect square. X plus 3 squared equals 10. Now we can undo that perfect square by taking a square root. We're well on our way to solving this equation. X plus 3 squared equals 10. Let's take a square root of both sides. And I have x plus 3 equals the positive or negative square root of 10. Once again, let's remember positive and negative roots whenever we take a square root as part of solving a quadratic equation. I'm going to solve for x simply by subtracting 3 from both sides. So minus 3 minus 3. Usually how we would write the right side of this equation here is x equals negative 3 plus or minus root 10. That represents two different solutions. One of them is negative 3 plus root 10, and one of them is negative 3 minus root 10. This is just a more compact way of reporting our solutions. Either of those solutions will solve this quadratic equation. So here in this example, our solutions are irrational, right? Which means that we would not be able to find them by rearranging this equation and factoring the trinomial. This represents a trinomial that cannot be factored. The solutions are irrational. The only way to find those solutions are by completing the square or by using the strategy in the next video, the quadratic formula, which derives from completing the square. Let's look at one more example of completing the square. Here I want to solve x squared plus 4x minus 7 equals 0. Once again, if I could solve this by factoring, I probably would factor it to solve it because that's a little easier. However, this trinomial is prime. It cannot be factored. That doesn't mean there are no solutions to the equation. There might be irrational solutions. We just have to find them some other way. So let's complete the square. I'm going to rewrite this equation with the x terms on the left and the constant term on the right. So it looks like x squared plus 4x equals 7. And then we're going to add something to both sides of this equation, here and here, in order to create a perfect square on the left. What do we add? Well, we take this, we divide it by 2. So 4 divided by 2 is 2, and then we square it. 2 squared equals 4. So we're going to add 4 on both sides of this equation. What did I just create? On the left, I made a perfect square. This factors as x plus 2 times x plus 2. And that's going to be equal to 11. So I have x plus 2 squared equals 11. Notice this structure. I have the perfect square isolated on the left, and I have the constant term on the right. We're ready to undo the perfect square by taking a square root. Then I have x plus 2 equals positive or negative root 11. And let's subtract 2 from both sides and write our answer as x equals negative 2 plus or minus the square root of 11. Once again, our answer is irrational. And this represents two solutions, negative 2 plus square root of 11 and negative 2 minus square root of 11.